Hello, I'm Tarte, math teacher. This is mid-December 2013. Having retired from classroom teaching 8.5 years ago, I am now self-employed as a private math tutor in students' homes. Most of my students have been in high school, but I have a 5th grade student, Nick, and I enjoy tutoring him because he is interested in math and eager to learn. In this video, I invite you to watch highlights from my lesson with Nick yesterday. I had parental permission and Nick's permission to record the session, and I have their permission to make this video. In math class at school, Nick is studying something that I did not study in the 5th grade, XY tables. He is looking for patterns in numbers. So you will see me doing a little reviewing with him, and then I will try to lead him into territory that is somewhat unfamiliar to him. You will see me try to guide him to make some discovery, and you will see how he responds. I hope you will enjoy watching. Before I show you the lesson highlights, I want to say this. You will hear background noise. The family just moved into a new home, and Nick's mother and sister were unpacking things in the kitchen adjacent to where Nick and I were having our lesson. The very sensitive microphone of my MacBook laptop picked up that background noise quite audibly. Nick and I pretty much ignored the noise. I hope the background noise will not be too much of a distraction to you as you watch these excerpts from our lesson. So we've got in the X column 1, 2, 3, 4, 5, 6. In the Y column we've got 4, 8, 12, 16, 20, and 24. What can you tell me about that would and leading to an equation for it?
Well, the pattern of the table is times 4.
That's right.
So it's multiplicative table.
It is multiplicative. That's right.
And you do almost always you do the y first.
Yes.
So
we read y equals something.
Y equals x times 4.
That's right. Now I'm going to put another x here. We've got x's 1 through 6, and they're y's. Suppose I jump to 20 as an x. What y should go alongside the 20?
It would be 80.
That's right.
Because still the pattern is times 4.
That's right. Whatever.
No matter what number it is, it's still times 4. That number.
That's right. A little bit more review. Here is another XY table that is pretty much different from those. Can you analyze this table and tell me something about it and ultimately write a formula for it?
Well, just by the table, it cannot be multiplicative.
That's so right. And by the way, for those who are watching, in the X column I have 1, 2, 3, 4, 5, 6. In the Y column I have 6, 7, 8, 9, 10, 11.
And it's not subtracting and it's not dividing, so it's additive.
You're right. It is.
It's an additive table.
That's correct.
And the pattern of this additive table would be plus 5.
That's right. So what's the complete formula for it?
The formula is y equals x plus 5. And
That's
that
right.
is your formula.
That's right. Now choose a much bigger x and determine the y that goes with it. So your x is 1,000, okay?
Yes. And your formula is still, or your the pattern for this additive table is still plus 5.
That's right.
So it is 1005.
1005, that's right. So,
technically, you can go as high as numbers can ever imagine.
that's right.
But all you have to do is add 5 to your number.
That's right.
So it's
So,
not too complicated.
What could these numbers refer to in real life?
They can refer to people's ages.
That's right.
And not miles per hour.
That's right. This miles per hour wouldn't make sense.
The table does not calculate for.
If it's referring to two people's ages, what would you say about their two ages?
Well, they, like, just for an example, Frank and Bill.
Yes.
Frank is 5 years older than Bill is.
That's very good.
And that's how it will be every time.
That's right. Okay, now I have another type of XY table in mind.
Yes.
Which will be different from these. In these three multiplicative tables or this additive table, in each case, as x gets bigger, what does y do?
It also gets bigger.
That's right. I'm going to make up a table in which it's not like that and ask you to analyze it.
It's different?
Yeah, yes, you'll see. I'm going to put a limited number of XY numbers in here, and if you have difficulty analyzing it, I'll give you more to go on. But we'll start with this. When x is 3, y is 97. When x is 4, y is 96. When x is 10, y is 90. When x is 20, y is 80. Does that give you any idea of what I'm doing?
Well, you're subtracting or dividing.
Say that again?
You're either subtracting or dividing.
Oh.
Because y is bigger than x.
Well, let me put another one here. When x is 40, y is 60. Here's one where this y is bigger than this x.
Well, this pattern would be plus 20.
Okay, does plus 20 fit the others?
No.
No. What we have to do is try to find a pattern that fits all of them.
All of the XYs.
Right.
So, how do you get from 3 to 97?
Right.
How much?
Or we could rephrase the question. What is a relationship or a connection between 3 and 97, which is also true of the other pairs?
Another shortcut that I have learned, you can, to figure out, you can just do the 97.
So you're subtracting 97 minus 3, you got 94.
And that's how much this and this is to get that.
Okay, well, does that apply to the other XY pairs also?
No.
No, it doesn't. So you found something that works for one of them that doesn't work for the others. Still isn't something that works for all of them.
Do you think it could be division?
Nope. Division would have to be consistent, such as, the thing is, here the y is bigger than the x, but in most of these the y is bigger than the x, but here's another one. 60, 40. Here the y is smaller than the x.
Yes.
And here's another one,
Well,
50, 50, where they're both the same.
Well, this would be minus 20 to get 40.
True.
And that would just be equal 0.
That's right. Again, you're finding something that works for one of them, it doesn't work for others.
All of them.
Right.
Well,
I'll put a couple more in. I'm putting in 90, 10, and 99, 1. Something that all those pairs of numbers
90,
have in
10 would be, that would be minus 80.
That's true.
And this would be minus 98.
That's true. Still mysterious.
Well, the numbers keep on going up 10. Well, like, it went from 98 to 80. That's minus 10 from each of them. So, would this be 98, 88, 78, 68, 58, 48, 38, 28, and then 18?
No, not exactly. Maybe I should really make it long, and there's so many numbers missing, but maybe this will give you a better idea. For x, I put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And for y, I put 99, 98, 97, 96. Can you fill in some more y's? You're writing 95, 94, 93, 92, 91, and 90. That's right. I put these in, but I put what goes in between also. Well, does that help any for you to see what they all have in common?
Yes.
What?
Forgot about it. It's all wait,
I'll be back. I'm gonna go wash this out for conditioner. Okay.
these all have different patterns.
I'm going to give you a hint here. I'll write it also. You do something to any XY pair in this table, and you always get the same answer. that's my hint to understand the pattern in this table.
You do something to any XY pair in this table, and you always get the same answer. Then,
And it applies to every XY pair you see, not only in this table, but this one also.
then it's 1.
What do you do? What are you thinking of doing to the two numbers?
Add.
Okay. So if pick a pair and add them and tell me what you get.
98 plus 1 equals 99.
No. Add the two numbers that I wrote. Add the X and the Y. Don't think of what you do to one to get the other, but do something to both of those. Add the X and the Y that go with it. Such as add these two numbers.
100.
Okay. Now pick another XY pair and add them.
They all equal 100.
Show me.
For the
Show me
pattern.
with several.
98 plus 2 equals 100.
Yeah.
97 plus 3, 96 plus 4, 95 plus 5, 94 plus 6, 93 plus 7. They all equal 100. 93 plus 8, 91 plus 9, and 90 plus 10.
Okay. Does that apply to the numbers that I gave you over here also?
Yes.
That's right.
They do.
They all fit. They could all fit in the same table. That's right. So when I say you do something to any XY pair, what is that? What is that something that you do?
That's if you do the thing to that, then you do the same thing to all these other
But
pairs.
what did you do in each pair?
I added
Okay, so you add
each pair.
any XY pair, and you always get the same answer. And what is that same answer?
100.
Okay, that's right. That's the key to this. So can you put that idea into an equation that contains both letters X and Y? And it doesn't have to say Y equals. You can write it whatever way makes the most sense to you.
All right.
It may make more sense if you don't try to write Y equals. Try to write it some other way. Try to write it that expresses this idea right here.
It's the all of these numbers right here equal 100
That's right. What symbol do you write for the word add?
plus.
Okay, write a plus sign. Okay,
Plus.
now I'm going to put a blank in front of the plus sign, and a blank right after the plus sign, and I want to put an equal sign here, and a blank after the equal sign. So I've got 3 blanks here. I'm asking you to fill in the blanks so that this will say what this meaning is.
Can it be any number?
No, I want you to use the letters X and Y because it should describe all those pairs.
X plus Y equals 100.
That's right. You wrote a
Oh.
9 instead of a Y. That's right. X plus Y equals 100. That's right. That's a new kind of formula. It doesn't say Y equals.
And that's also like algebra.
That's true.
Algebra.
And anytime you use a letter, one or more letters to stand for numbers, you're using algebra. That's right. Okay, so as we did before, we now have this formula, which is a really good formula. So I will put another X here that we haven't used yet, and this time I will choose it. It will be 52. I put 52 in the X column. What number should go beside it in the Y column?
48 plus 52.
That's right. So what can you do to 52 to get 48?
I know that the whole thing is 100.
Yes.
So 52 plus 48 equals 100.
Okay.
So I got it.
So what do you do to 52? I want to write this. What do you do to 52 and 100 to get 48? So you're writing 100 minus 52. Okay, go ahead.
10 minus 2 is 8. 9 minus 5 is 4. And
That's
I got
right.
48.
That's right. You subtract 52 from 100.
You subtract your pattern from the X, and that's how you get your Y.
Say that again?
How you get 48 is your pattern, which is 100, minus your X, which is Y.
That's right. 100, I'm writing what you said, 100 minus X
Equals Y.
equals, we'll put the Y in front. That's right, Y equals 100 minus X. So there is a formula that, like these others, says Y equals.
Yes.
So these are two good formulas. They're about equally good. X plus Y equals 100,
Yes.
and Y equals 100 minus X. One more point before our lesson ends, and that's to imagine a situation here. And I have a situation in mind, and maybe you can help me with it.
Okay.
You are taking a car trip of 100 miles. So far, you have gone, this is a very short story, and I wonder if you can complete the story based on what's on this page.
Yes.
You are taking a car trip of 100 miles. So far, you have gone...
You're taking a trip of 100 miles.
60 what? We're not talking about miles per hour. We're only talking about how far you've gone. We're only talking about how many miles
60
you've gone.
miles.
60 miles, okay. We'll change that to 60 miles. So far you've gone 60 miles. Now, what sentence can you write to finish this story?
Well, if your trip is 100 miles and you've gone 60 miles.
So you're writing 100 minus 60. Oh, you don't need to borrow here because you just have 0 minus 0.
Yes.
And then 10 minus 6.
That's 10. So 0 minus 0 is 0. 10 minus 6 is 4. And
so
40.
What does 40 mean?
That means you've gone 40 miles per hour your whole trip.
No, we're not talking about miles per hour. We're talking about how far you've gone.
Or you've gone 40 miles.
So far, you have gone 60 miles.
And you have 40 miles to go.
That's right. Write that sentence. That completes the story. Okay. There's an XY pair on the page. I wrote it. Can you find the XY pair for this story that we just made up? with the 60 and the 40? Yes, right there. You have gone 60 miles. We have this one. X will be the number of miles you've gone, and Y is the number of miles still to go.
Yeah.
Could we say you're taking a trip of 100 miles? So far you have gone X miles. You have Y miles to go. Does that make sense?
No. Well, wait.
Well,
yes.
if you've gone 3 miles, look at this pair. If you've gone 3 miles, you have 97 miles to go.
Yes.
If you've
So
gone,
it is X equals Y, and that does make sense.
that's right. So this is a story with X and Y that fits this whole table. It fits this equation, X plus Y equals 100, and
that equation.
this equation, Y equals 100 minus X. Okay,
Well,
you did very well.
Well, thank you, Mr. Tarte.
You're welcome. Well, at one point in the lesson, I disappointed myself not doing what I planned to do. However, all in all, I think it was a very good lesson because of Nick's consistently good response. I hope you enjoyed it. Thank you for watching.